Hello, I am Midae of the team lab, Department of Industrial Systems Engineering, Dongguk University. First, the bibliographic information of the study. The study is a paper published in the journal Technological Forecasting and Social Change in 2022 and aims to discover technological opportunities from the perspective of new technology-based firms and investors by using deep learning-based text mining and knowledge graph. Table of contents is as follows. New technological-based firms are growing at a rapid pace, forming a new technological innovation ecosystem specialized for NTBFs. As new technologies emerge, NTBF attempts to leverage and commercialize the least promising technologies, and in this environment, discovering technology opportunity is critical. To respond to this demand, technology opportunity discovery is necessary, which is a way to identify emerging technology opportunities and quickly react to them. TOD can evaluate the potential value of technology and discover promising technologies with great future value, but existing TOD research only focuses on evaluating technology. Searching the company's portfolio to find a technology opportunity that is suitable for the company. So, the aim of this study considers the trends in NTBF and their technological innovation ecosystem to represent the marketability in real business. This perspective has never been explored before, despite the important contributions of NTBF to advances in technology. This study proposed a new TOD analysis framework using NTBF and their investment data along with technological documents and deep learning-based text mining and cage to develop methodologies suitable for the data. And this study used DoctorBack to generate the document representation for TOD analysis. And for the TOD KG, the connection between nodes and is composite of the similarity of text embedding between technologies or NTBF as well as the link limits of direction technology classification and investing behaviors between technology and NTBF or between NTBF and investor. So, this study proposed a new TOD index derived from the TOD KG to quantify emerging technology opportunities. The amount of data has increasing rapidly and continuously, so TOD studies have moved towards automated data processing to supplement expert-oriented technologies. Patent and scientific articles summarize R&D research and are rich sources of technology information, mainly in the form of text. So TOD studies that have used such data have attempted to identify technology opportunities by utilizing keyword search methods such as keyword morphological metrics and a keyword matching algorithm. This method can identify semantic similarities between technologies and identify potential technological opportunity, but cannot discover contextual semantic information because they only consider the frequency of keywords extracted from technological documents. To overcome the limitation of keyword-based method, TOD studies have used machine learning-based text mining method. Advances in the learning-based text mining algorithm have been exploited in recent TOD studies. They have focused on neural network-based text embedding method such as word-to-back, which generates word presentation to capture the context of the document. Network analysis is an approach to quantify interactions between actors. Several researchers have proposed this type of the TOD framework, including subject action object network and patent network, because it can effectively represent the relations among the technologies. Some TOD studies that use patents have generated a patent network that is composite of patents as nodes and patent relationship as links. Overall, previous studies that used patent network have enabled the identification of technology opportunities by identifying visual patterns and have permitted evaluation of opportunity by measuring several network quantification in this, but the study have limited ability to represent external factors that can be highly correlated to trends of technologies. Recently, several studies have conducted TOD by using corporate technical data such as corporate portfolios and patent data owned by companies. These studies have suggested ways to discover promising technology suitable for the characteristic of the target company for its R&D planning. In similar context as the peer studies, our proposed framework defines an effective TOD index that represents the corporate perspective by using deep learning based text mining and network analysis. However, no study has analyzed to TOD for NTBF and their investors, despite the importance of such factors. TOD framework considers three data set: technology text data, NTBF data, and data on investors who have invested in NTBF. First, we collected the technological data, the TRM, which is a report that summarizes trends in promising technology sectors in South Korea from 2016 to 2019. Next, we collected the NTBF data from the Punch website. Punch is one of the large business networking platforms in Korea, where numerous companies, including NTBF, participate and share the reliable corporate information to promote themselves to investors and job seekers. Punch data includes the company's various information, such as its technological investor relation text, news text, the year of establishment, and funding information. Finally, we collected investment data about 121 investors who invested in the NDPF from local funds. We propose a new TOD framework that consists of 4-page figure 1, first technological classification and NDPF technology categorization, next TOD case generation, and emerging technology discovery. To be specific, first, page 1, technology classification. Technology classification is vital processes that can allocate suitable technology for technology text data, even if the input is composed of technological text data without specific labels. In the page, we construct the Ductable error classifier for technology classification in two steps: Ductable training and error training. After extraction of document embedding, we assign technology labels to each document by using the multinomial error model that presented the best accuracy and F1 score in preliminary experiments. We obtain a technology classification model called Ductable error, trained with technology relevant text data. Next, NTBF's technology categorization. to analyze the TOD effectively by representing NTPF information, unified technology category leveling for the NTPF is essential because it enables intuitive identification of their technological field. But generally, the NTPF data has no clear and consistent technology category information. So the goal of this page is to assign each NTBF to relevant technology by applying the Dr. error model to the NTBF couples. Next, we apply the Dr. error classifier to the preprocessed NTBF couples. The modified method can identify the concurrent technological characteristic of NTBF. Next, in this TOD cage generation, in this study, we aim to evaluate the potential value of technologies by taking the technology, NTBF, and investor information into account for TOD analysis. To approach the problem, one possible way is to first construct a new data structure that can represent the interaction between various subjects compressing the NTBF ecosystem. A KG is heterogeneous group that represent different types of entities and their various relationship. In this case, by adopting the definition of KG, we newly construct the KG for TOD to effectively integrate the information about objects that have different properties in the NTBF ecosystem as a single form. Our new KG is a fundamental data structure suitable for the purpose of this study, which is used to quantify the value of land technologies by reflecting intrinsic relationship between the of the group comprehensively. Next, emerging technology discovery. TOD analysis urgently requires a precise and overall index to quantitatively evaluate technology opportunities. So we introduce a TOD index that is calculated from the TOD KG by measuring the network centrality to represent the influential power of these entities of TOD KG. The assumption of the TOD index is that a high centrality of technology can represent a high potential value of technology opportunities in the NTBF-related technological ecosystem. Specifically, in this phase, we generate a technology opportunity index TOI by aggregating the three different TOD indices of technology index, an NTBF index, and an investor index. In terms of this perspective, the TOI can represent the characteristics of main subject and their relationship in the NTBF ecosystem. Results for technology classification results, we first implemented Doc2Vec to vectorize the TRM documents. We compared the accuracy of Doc2Vec error with the baseline models for the technology category and subcategory classification. The classification accuracy of Doc2Vec error for category is superior to that for subcategory, but it shows remarkable accuracy. These results indicate that the back-to-back training processes reflecting the characteristic of both category and subcategory can be an effective way for improving the accuracy of technology classification. And we applied the Dr. error to categorize the adequate technologies of 118 NTBF. We verified the NTBF technology categorization in terms of qualitative and quantitative analysis. And the pre-trained Dr. error model could accurately categorize the technology of NTBF. To be specific, in the case of AI, big data, and biohealthcare categorized words such as healthcare, disease, nutrition, patient, and big data are prominent in the NTBF corpus. Next, for the quantitative evaluation, we compared the average cosine similarity of TRM and NTBF documents assigned to the same category with that of TRM and NTBF documents assigned to different categories of each other to sum up both qualitative and quantitative evaluation results verify the accuracy of NTBF categorization using the proposed back-to-back error model and demonstrate the applicability of our model to technical text data that differ from TRM data. And we conducted TOD KG generation using the technology and document embeddings extracted from back-to-back and the relationship of NTBF and technology labels from NTBF technology categorization. Furthermore, we only considered technology subcategorized and as the technology nodes of TODKG. Finally, 77 NTBF 42 technology subcategorized and 83 investors who invested in the NTBF involved in such five categorized were connected in the TODKG. We identified the core subcategory technology nodes such as big data software, AI software, and fintech big data analysis and application service intuitively, which are densely cohort to NTBF and investor nodes. Given the TODKG, we performed the emerging technology discovery by calculating the TOI, TI, NI, and II for 42 technology subcategories allocated to 77 NTBF. Most of the top 5 ranked emerging technologies sorted by the TOI are related to AI and big data or to convergence between AI and other fields such as finance. On the contrary, most of the bottom 5 ranked technologies are involved in games, health, food, and chemistry. TI and TOI show top tier scores to similar emerging technologies, but NI and II give top ranks to technologies that differ from those identified by TI and TOI. This result demonstrates the various perspectives can identify different emerging technologies. Discussion. This study discovered the emerging technology opportunity using this TOI proposed by reflecting the NTBF ecosystem. For the evaluation, we instead consider economic valuation from the real investment decisions of venture capitalists who invested in the NTBF. This decision could be reliable evidence of the perceived value of emerging technologies present by the NTBF ecosystem because the investors' main considerations include the value of and novelty of an NTBF technology and further future growth of the NTBF. Our proposed TOI shows statistically significantly higher average IFS and IAS. This section aims to provide an interpretation of emerging technologies that were identified using our proposed TOD index across various industry and academic fields. We also analyzed the results of NI, TI, and II to show different perspectives for the TOD. How, consequently, the future value of the healthcare industry has increased as a result of convergence of AI and healthcare technology, but remains an industry in which technology opportunities coexist with risk. Conclusion, this contribution of research. This study presents a new systematic framework to identify potential technology opportunities. This study proposed a text mining technique that uses Dr. and error model to develop a technology classification model called Dr. error. Then it categorized each NTBF accurately into technology fields, and this study constructed the TODKG consisting of three factors: technology, NTBF, and NTBF investor. This study analyzed the top scored promising technology as identified by TOD indices and provide evidence and interpretation of technologies with the actual situation of the practice industry. So this study proposed a functional technology intelligence system for providing the meaningful TOD indices, and our research will be a basis for the TOD to represent the information of NTBF and investment. S- But we used the data that had already been accumulated from the past of our TOD analysis, so the analysis should be repeated on the latest data to identify whether the changes causes the difference in the predictive evolution of future technology. However, most of these models or systems need to update it periodically to obtain the latest analysis result when new data is accumulated. Regarding this, our framework can be easily implemented again by preprocessing in the form of input data to the framework even if the data is updated. Thank you for listening.